So this is the Hygens principles, second wavefront, okay, which is created over here. So Hygens principle states that each point of the wavefront is the source of secondary wavelets, that is small waves. This is the primary wave. Each point of the wave creates the secondary waves, and because of that, the next secondary wavefronts which is created over here. This is the V. V2 is the back side of the wavefront. The V1 is the front side of the wavefront, which is created over here. So the new wavefront is formed by drawing a line tangent of all the wavelets. So for example, if a stone is thrown on the river, waves will be formed surrounding that point, that we have already seen it in the animation form. Okay, these waves look like concentric circles and they are known as wavefronts. These wavefronts gradually spread in all the directions. Okay, so when the locus of all the waves is joined, which are in the same phase, it will be as the same as a sphere and are known as primary wavefronts. Secondary wavefronts are formed from each point of the primary wavefronts. Okay, this point is that you should understand for Huygens principle. Okay, the common tangential line that envelops these secondary wavefronts will further give rise to the secondary wavefronts. So all wavefronts will gradually fade after some time. Fade after some time means the strength of the waves will reduce and it will fade. Okay, that's what we understand. So this is the primary wavefront which is created, and this is the secondary wavefront. Tangent is drawn over here. So like waves are propagating primary and secondary wavefront, and primary wavefront, the waves will continuously overlap each other. This overlapping will create a wave. So this is the primary points in the on original wavefront, and this is the wavefront which is created like this, and this is the overlapping secondary wavelets created, and this is the new wavefront which is joined over here. So as a conclusion, according to the Huygens principle, every point on the wavefront gives rise to the secondary wavelets, which spreads out in all directions with the speed of the wave. If it is considered as a light, it moves into the speed of a light. If it is considered as a water, how the water propagates, that is the speed that we can consider over here. Okay, so this is the example. So using Huygens principle, we can determine that new position of the wavefront after time t. So mathematically, if you take it out, to calculate the new position of the wavefront after time t, let the initial time ti is equal to 0. Each wave will travel speed of the wave into time t1, where v is the speed of the wave. Okay, distance traveled by the each wave is equal to the radius of the sphere. Radius of the sphere, we can consider that it is in the same direction, same direction, in all directions, same distance it will propagate. So therefore the radius of the sphere is equal to v into t1, that we can consider over there. So the common tangent joining all the shapes will give the position of a new wavefront at t is equal to t1 time. So there are two possibilities. What are the two possibilities? Outer tangent and inter tangents. As I have already told to you, the amplitude of the backside wave is 0. So therefore, the back wave is neglected and the forward wave is only considered. New wavefront will arise from each point on the outer wavefront. So therefore, the distance covered by these wavefront is v into t2. So again, its spreads will be obtained by drawing common tangent tell the position of the new wavefront. Like this, all the wavefronts are keep on moving in one particular direction. Again, back wave is neglected, forward wave is considered. So this shows that the wavefront is keep on spreading with respect to time. Okay, let us finish this video here, and we are going to see the mathematical derivation of the waves which is moving from one particular medium to another medium in the next video. Thank you.